Hi, everybody. It's Professor Mitchell. We're continuing with Chapter 10, and today we're looking at Section 10.5, Rationalizing Denominators and Numerators of Radical Expressions. In this section, we'll rationalize denominators having one term, which includes square roots and other kinds of roots. Then we'll rationalize denominators having two terms. And finally, we'll look a little bit at rationalizing numerators. And this is still part of SLOB. All right, so big question about doing this is why do we do it? And of course, I'm going to have to explain to you what it means. So back in the old days, when you saw an expression like 1 over the square root of 3, and you had to calculate a decimal approximation for that. Well, back in the old days, people did not carry calculators around. So the first thing they had to do was they had to calculate or approximate the square root of 3 by hand. And then what I think may be almost as bad, switching over to the tablet, is you would figure out that the square root of 3 is about 1.732. And then to get a decimal approximation for 1 over the square root of 3, you would have to do long division 1.732 into 1. So I don't know how long it's been since you've done that, and I am certainly not going to do it, but it's one of these things where you have to move the decimal point 3 places this way, and then that means you got to move it 3 places this way, and then tack on a couple more zeros over here, and on and on and on. It's a big pain. So one day, some very clever person figured out if I could rewrite this expression so that the denominator is a whole number, then that long division would be a lot easier. And the way you do that, if the denominator is just a single square root, it's very easy. In this case, you would just multiply the top and the bottom by the square root of 3. Because remember, I think this was just in the last section, we talked about this shortcut that said that the square root of a times the square root of a is equal to a. So when you do square root of 3 times square root of 3, you just get 3. All right, and then I don't care if the numerator is a square root, because long division, if the big ugly decimal is what we call the dividend, inside, that doesn't matter. So instead of doing this horrible long division here, you would just have to do 3 into 1.732. And then that's very easy. I don't mind doing that. 3 into 17 goes 5. 17 minus 15 is 2. And that goes 7. All right. You get the idea. All right. And that is basically the idea. When your denominator is just one square root, this is all you have to do. You just multiply the top and the bottom by that square root. So rationalizing the denominator means rewriting the expression so that it does not have a square root in the denominator. All right, now I just want to say one other thing about this. So now, of course, it would be totally fair to ask, okay, but why do we still do this? All right, everybody's carrying a calculator around. It's no longer a big deal to divide 1 by 1.732. Well, we don't really do it for that reason anymore, but it is still needed as an algebraic tool for doing certain problems in higher level math. And I'm going to show you an example in a little bit, give you a little taste of a calculus problem. All right, so again, if you're rationalizing the denominator and there's just a single square root in the denominator, you just multiply the top and the bottom by that square root. It is helpful, I think, to simplify that square root first, if it's not already in simplest form. All right, so let's look at these for examples. I'm going to switch back to the tablet. All right, starting with 3 over the square root of 2. So since I just have the single square root of 2 in the denominator, I'm going to multiply the top and the bottom by square root of 2. All right, downstairs I just get 2 because square root of 2 times square root of 2 is 2. Upstairs I get 3 times the square root of 2. And remember, if I'm rationalizing the denominator, I don't care if I have a radical in the numerator. Okay, so this would be the simplified form of 3 over the square root of 2. All right, letter B, you have a fraction under the square root, so that is not considered simplified. So the first thing I'm going to do is use my quotient rule for radicals to rewrite this as the square root of 25 over the square root of y, which of course is 5 over the square root of y. And now to get that square root out of the denominator, I will multiply the top and the bottom by the square root of y. And of course, the square root of y times the square root of y is y. And upstairs, I'm left with 5 times the square root of y. Isn't that easy? All right. At any time, please feel free to pause the video, try it, come back and compare notes. Now for this one here, 5 over the square root of 27a, I would suggest simplifying the radical first. Notice that the square root of 27a is not in simplest form because 27 has a perfect square factor 9, right? So if we write this as 9 times 3a, break that 3 out, break that 9 out of the radical, it becomes a 3. So that would be 5 over 3 square root of 3a. And now to get rid of the square root of 3a, I will multiply the top and the bottom by square root of 3a. All right, so let's break this one into 2 steps maybe. Upstairs, I have 5 over the square root of 3a. Downstairs, I have my original 3 right here. And then let's take these two and combine them into square root of 3a times square root of 3a would just be 3a. All right, so to finish it off, just do 3 times 3a in the denominator. You end up with 5 square root of 3a over 9a. Done. All right, and then finally we have the square root of 11y over 45. This would be a great one for you to try if you haven't tried one yet. All right, there's absolutely nothing new that's going to come up in this one. All right, so first, use my quotient rule, rewrite this as 11y over, or square root of 11y over the square root of 45. And now square root of 45 is not in simplest form because it has a perfect square factor 9. So let's do square root of 11y over the square root of 9 times 5. And just like in the last problem, the square root of 9 is 3. So this is going to become 3 square root of 5. And now I'm going to multiply upstairs and downstairs by the square root of 5. All right, and that is going to give me the square root of 11y times the square root of 5 is the square root of 55y. Note that is in simplest form because 55 does not have any perfect square factors besides 1. And then the square root of 5 times the square root of 5 is 5. I'll do it like this time. And 3 times 5 is 15. All right. And then whenever I see this one, I always think to say, if you're looking at that 55 and that 15 and wondering if that fraction can be simplified, it can't because the 55 is under the radical. All right. If it was 55 outside the radical, then I could simplify that. That I'm just going to leave just the way it is. All right, so let's see what's next. All right, so now let's look at simplifying or rationalizing denominators involving nth roots. For example, 2 over the cube root of 3. So after what we've just been through, you might think, oh, okay, no problem. Just multiply the top and the bottom by the cube root of 3. Would that work? Well, let's see. Let's try it. Okay, so I'm going to try multiplying the top and the bottom by the cube root of 3. Upstairs, that's going to give me 2 times the cube root of 3. Okay, now let's be careful here. We know that the square root of 3 times the square root of 3 is 3. But the cube root of 3 times the cube root of 3, let's forget about the shortcut here for a minute and just use the product rule, which is where the shortcut came from. The cube root of 3 times the cube root of 3 would be the cube root of 3 times 3. Well, 3 times 3 is 9. And I'm sorry to tell you that the cube root of 9 is nothing special. All right. So that is no help. All right. My denominator is not rationalized. So the idea is, instead of multiplying the top and the bottom by the cube root of 3, we need to multiply by something that will make a 3, a plain old 3 in the denominator. All right. And so what I say to you is the thing that will get that done is not the cube root of 3, but the cube root of 3 squared. And we will talk about why that is. Okay. All right. I don't really care what's upstairs, right? What's really important is what's downstairs. So using the product rule, this would, hang on a sec. I would really like to break this into 2 steps if I can. Okay, that should work. All right, this would be the cube root of 3 times 3 squared. Well, guess what? 3 times 3 squared is 3 cubed. And I do know that the cube root of 3 cubed is 3. So that will work. All right, so now we might as well look at what's going to be in the numerator. Well, it'll just be 2 times the cube root of, and instead of writing 3 squared, I'll just write 9. Okay. And nothing's going to happen with that. It's just going to come along for the ride and be part of the answer. All right, so that would be the rationalized form of 2 over the cube root of 3. Okay, so the idea is that you have to make perfect nth powers inside that radical. So in the case of a cube root, they would have to all be perfect cubes. Okay. All right, so I think we're going to come back to the tablet here just a second, but let's, okay, so we need the denominator to be 3, and we saw how to do that. All right, so here are the examples we're going to look at. All right, I will take these nice and slow. Rationalizing denominators with nth roots, I think, is a little trickier. It takes a little more getting used to than square roots. Square roots are really, really easy. Okay, so what I suggest whenever you're doing an nth root is that you prime factor your radicand. Remember, the radicand is what's under the radical. So in the case of 9, it would just be 3 squared. And then I would suggest maybe that you think about, okay, how do you make that cube root of 3 squared into cube root of 3 cubed? Because you know that's how you're going to get your 3. So in this case, since I already have 3 squared, what I need is another 3, because 3 squared times 3 is 3 cubed, right? And whatever you do to the bottom, you have to do to the top. So that is going to give me 6 times the cube root of 3. And if I remember correctly, I think I kind of rigged this one so that at the end it would simplify, right? I have 6 times the cube root of 3 over 3. So what I can simplify with this one is the 6 over 3. As usual, that simplifies down to 2 over 1. So the final answer for this one is 2 times the cube root of 3. Okay, so we're rationalizing the denominator. If the denominator comes out to 1, that's like the best thing that can possibly happen. It means the answer doesn't even have to be written as a fraction. I love when that happens. All right, next. Next, we have a 4th root. So it's the same idea. In this case, we have the 4th root of 7 over 12. So as usual, I am going to start by using my quotient rule to rewrite that as the 4th root of 7 over the 4th root of 12. And now I'm going to prime factor that 12. All right, so we'll do that over here real quick. 12 is 4 times 3. 4 is 2 times 2. All right, so let's rewrite that 4th root of 12 as the 4th root of 2 squared times 3. Okay, so here's what we need to happen in this case. We have, under the 4th root, 2 squared times 3. What we need under the 4th root are all 4th powers. We need 2 to the 4th, 3 to the 4th. Okay, because that's how we're going to simplify that radical down to, it's just going to be 2 times 3. Okay, so how do I get that 2 to the 4th times 3 to the 4th? Well, I have 2 squared, so I need another 2 squared, because 2 squared times 2 squared is 2 to the 4th. I have a 3, and so what I need is a 3 cubed, because 3 times 3 cubed, I think I just discovered something by accident. I've always kind of wondered how to make straight lines on here. Okay, that's not what I would want to do right now, but I'll try to remember that for next time. 3 times 3 cubed is 3 to the 4th. All right, so if that's what I'm going to do to the denominator, then that's what I need to do to the numerator. 4th root of 2 squared times 3 cubed. All right, so that's going to give me a great big 4th root upstairs. It's going to be 2 squared times 3 cubed times 7. So I guess now we might as well start thinking about what that is. 7 squared is 4. 2 squared is 4. 3 cubed is 27. You know what? Let's just do it like this. 2 squared is 4. 3 cubed is 27. Okay, so 4 times 27 is 108. 108 times 7 is 756. So believe it or not, the simplified rationalized denominator form of this answer would be the 4th root of 756 over 6. All right, that was a little bit of a workout. All right, finally, we have 9a over the 5th root of 4a to the 4th, b to the 8th. So the first thing I noticed about this one is that 5th root can be simplified. How do I know that? Because there is a power under there that is bigger than 5. That means that I can break off a perfect 5th power, which would be b to the 5th, And then the 4a to the fourth, b to the third. That would be what we've always called a leftover. Okay. All right, so you break that b to the fifth out of the fifth root, and it just becomes a b. And then you're left with the fifth root of, let's write that 4 as 2 squared, because that's really helpful to build up your perfect fifth powers. Okay. All right, so what do we need over there in order to rationalize this denominator? We need everything under the fifth root to be a power 5. We need 2 to the fifth, we need a to the fifth, and we need b to the fifth. Okay, and let's remember that we have this b here outside. All right, so let's look at what do we have and figure out what do we need. We have a 2 squared. We need a 2 to the fifth. That means we're missing 2 to the third. Next, we have a to the fourth. We need a to the fifth, so we're missing an a. And then finally, we have b to the third. We need b to the fifth. That means we're missing a b squared. All right, so if that's what I'm going to do to the denominator, I had better do that to the numerator. 2 to the third times a times b squared. Okay, so that numerator is not going to be anything special. It's just going to be 9a times the fifth root of 8ab squared. And now we'll simplify that fifth root in the bottom. The whole point of fifth root of 2 to the fifth, a to the fifth, b to the fifth was so that it would simplify to 2. That is a really sad looking b. Let's try that again. We wanted that radical to simplify down to 2ab. Right? Upstairs we have 9a times the fifth root of 8ab squared. All right, so that leaves us with 9a times the fifth root of 8ab squared. Oh, you know what? Wish I'd noticed that a minute ago. I noticed we have a common factor a here that we can take out. All right, so final answer would be 9 times the fifth root of 8ab squared divided by 2b squared. And that would be my final answer.